Assalamualaikum and hi to everyone. Today, my team and I would like to present our problem-based task 1. First of all, let me introduce our team member. From the left is Muhammad Asfar, and the middle of the picture is me, Muhammad Shabil, and the last one is Haikal Rosli. For the question 1, we need to study the reflection of light by a flat surface, which is mirror, and refraction. For question 1a, we need to study about when light traveling through air encounters a three-frame material, part of the light energy is reflected back into the air. For this experiment hypothesis, here theta 1 is the angle of incident, theta r is the angle of reflection. Note that all angles are measured from the normal line. Law of reflection The law of reflection states the angle of incidence is equal to the angle of reflection. Thus, theta 1 equals theta r. For this experiment equipment, we need to have apparatus and materials laser pointer, protector plain white paper, box, pencil, and ruler. For the experiment, we have tests with various angles, which is 10 degree, 30 degree, 50 degree, 70 degree, and 90 degree. And I have calculated the sin value for each of the following angle, which is for the 10 degree, the value of sin is 0.174, and for the 30 degree, this value of sin is 0.5. 50 degree, the value is 0.766. For 70 degree is 0.940, and 90 degree is 1. Then we need to calculate for the angle of refraction, which is use the formula of refraction. N1 sin theta 1 equal N2 sin theta 2. One of the example to calculate the angle of refraction in this figure is at an angle of 10 degree. We have entered the value that has been given into the angle of refraction formula, which is 1 sin 10 equal 1.52 sin theta 2. In this figure, N1 is a air and N2 is a glass, which is 1.52 and air is 1. Then 1 sin 10 we can get 0.174 equal 1.52 sin theta 2. And then we need to divide 0.174 divide 1.52 equals sin theta 2. And then we can get 0.114 equals sin theta 2. And lastly, we can get the answer of theta 2 is 6.55 degree. Then, we repeat this step to find the angle of refraction at another angle for 30 degree, 50 degree, 70 degree, and 90 degree. For the scene R, I have calculated the value using angle of refraction, which is we can get 0.114 for angle 10 degree. For 30 degree, we can get 0.329, 50 degree, 0.504, 70 degree, 0.618, and 90 degree is 0.658. Refraction. Figure 2 shows an incident ray traveling from air to material X. Find the refractive index of material X. Okay, for this question, we need to find the refraction value and we will use the same formula from the previous slide. We fill the reflection formula, which is 1 air sin 40 degree from the incident, and X, we didn't know the value of N2 sin 30 degree. And then 0.643 for the answer 1 sin 40 degree equal X 0.5. And then we need to find the X value, which is we need to divide 0.643 divide 0.5, and the final answer for X is 1.256.
Okay, next I'm going to continue the slide. In any experiment, the array of light is directed toward or surface of water at an angle in increase of 15 degree. If a reactive index of water is 1.33, calculate first The angle of reaction formula is N1 sin delta 1, N2 sin delta 2. For the N1 is a reactive index is 1, and N2 reactive index is 1.33. For the delta 5 is 50 degree. So the all info you must to input on the formula, and the final answer is 25.2 degree. And the next question, to calculate the velocity of light in water, and the formula is N C bahagi dengan D. So dia punya N tu 1.33, and the for C 3/10⁸. So the final answer is 2.25/10⁸ ms. Next, for question 2. WDM is one of the technique in optical figure division multiplus. Explain the concept of WDM and WDM block diagram. For the answer, WDM is a fiber optic transmission technique that allows the use of multiple wavelength of light or color to transmit data over the same medium. In order to reduce transmission costs, multiples enable message to be transferred more reactively over the country communication channel. In input signal combined into one signal using a device as multiples. We process an input signal demultiplies separate in original component signal. A single fiber can carry two or more different color of light, and optical waveguide can carry multiple signal. A visual optical figure of red light. And next, this one is a WDM block diagram. So transmitter have three, so dia akan masuk dekat multiple flash, and dan dia akan keluar kat demultiplex. So dia akan pergi ke receiver. Contoh cahaya masuk kat sini dekat multiplex, dan melalui laluan ni dia masuk bawa data semua tu dan keluar ke receiver. That's all for me. I can pass to Haikal.
Okay, I'm Haikal. I will continue for question 3. The question is, upon which is passive optical network system utility splitter that takes one input and splits it to broadcast signals downstream to many users. Illustrate basic PON architecture, terminate diagram with different type of fiber to the load. Okay, a passive optical network is a system commonly used by telecommunication network providers that brings fiber optic cabling and signals are almost of the way to the end users, depend on where the points terminate. So in this diagram, you all can see PSTN is a public switch telephone network, internet, and IPTV. TV is a internet protocol television to send signal to each other. The signal travel over the cable, so going downstream to OLT sends the signal to a splitter, and the splitter sends the same signal to optical network termination and through to fiber to the home, which is FTTH, and also optical network unit send signal to fiber to the building, which is FTTB, and fiber to the car, FTTC. Okay, that's all from us. Thank you.